Started. Wanted to welcome everyone to the first of end user panel from Dry Scrubber Users Association. This one is talking specifically around circulating dry scrubber and the NID dry scrubbing solutions. Don't want to get into a big, long, in-depth intro because we've got some great speakers here and want to spend the time in hearing what they have to say. Again, this is the first one, so please bear with us. So again, this is intended to be a panel session. We've got some speakers I'll introduce, and we're going to have some topics. If you guys have questions, we're going to let them kind of talk and hear what they have to say and interact with each other. Anyone that has questions, you guys can submit the Q&A at the bottom. If you got to hop off early or someone you want to share this with, we're recording this and we'll be uploading it as we do for the other DSUA webinars. It'll be up on the website and we'll share it with everyone. So for future viewing purposes, real quick, I'll just give a quick shout out to all of our sponsors. We got our silver sponsors, Leckler, Atlas Carbon, Carton Fujikin. Our gold sponsors, Reaction Analytics Solutions Corporation, Primex, US Lime, Noltec. Our platinum sponsors, Lawast, IGS, Gecko Robotics, Redicam, RPM Solutions, National Filter Media, GE, Mississippi Lime Company, and Duramar. Thanks to those guys for their support this year. Want to turn this right over and get right started and briefly introduce our speakers. Today we've got Matt Wilson. Matt's a pollution controls engineer from TVA. You guys have seen him present at our webinars before. We've got Spencer Berrett. He's an engineering manager at East Kentucky Power Cooperative. We've got Gary Grubbs, who's a plant engineer at Gainesville Regional Utility, and Andy Szafarz. He's a process engineer with Alliant Energy. And we've also got Fritz. Fritz, I'm sorry, I'm going to butcher it. Sobolik, close?
Sobolik.
All right, I apologize.
Close enough.
Yep. He's an engineer too at Minnesota Power. So we're going to turn right over. We're going to start asking some questions to these guys and listen to what they have to say and give everyone a chance to speak. So I think the first one, a great place to start for everybody. Let's hear a general description about your CDS system so everyone listening in gets an understanding of what you guys have. Let's start with you, Fritz, since I just butchered your name and you're not on mute right now. So you want to go ahead and give us a description?
Perfect. Sure. We're at the Clay Boswell plant in northern Minnesota. We got about a 630 gross megawatt coal fired. That's sub bituminous, Wyoming low sulfur coal. And we have a inline 9 module Alstom NID dry scrubber. And we use our fly ash in that system. We have no precipitator or any other type of scrubbing up front. So it's probably a typically more abrasive mixture in our NID than a lot of others do. So.
Okay. Gary, you want to go next and describe your system?
I can certainly do that. I'm at the Deer Haven plant, about 250 megawatt plant, coal burning, converting to dual fuel capabilities as we speak. We have a hot side electrostatic precipitator, followed by our circulating dry scrubber that was supplied by BPEI. We have an integral CDS, followed by a pulse jet fabric filter supplied by Hamon. And then it feeds back into the existing chimney. So that's a little outline of where we are.
Okay. Andy, want to tell us about your CDS?
Unmute. Okay. I'm Andy Szafarz, and I work as the process engineer for 2 of our plants. Our Edgewater station is a 430 megawatt coal-fired unit, and the CDS is on the back of the plant. Behind the precipes and NID fans, and it's an Andrus dual train system with 6 modules per train for the bag house. And then on our Lansing station is a 270 megawatt coal-fired plant. Both plants burn PRB. It has a precip in front of the in front of the CDS, and it's a hot side precipitator, and then it has a B&W CDS vessel and a Hamon research control baghouse.
Okay, thanks, Andy. Matt, would you want to describe your system to us?
Sure. We've got 4 units at our Gallatin plant. They range from around 250 to close to 300 megawatts. Each has 4 Alstom NID modules, and they run pebble lime, and it's also full ash burden. So they've got a 10-meter length bag house pulse jet fabric filter behind it, and we utilize pebble lime.
Okay. And Spencer, how about you, sir?
Good afternoon. Here at Spurlock Station, we're a 4-unit plant. We have 2 wet scrubbers and then 2 dry scrubber NID systems that are coupled with a 300 megawatt CFB. So like a couple already spoke, we do have full ash burden on the bag houses and NID systems. And then we're also starting a new wastewater plant for the wet scrubbers, and we're using the clarified purged water as our water in the NIDs now. So
Okay.
really interesting.
All right. Well, thank you guys. Helpful to kind of hear. There's a good mix of what everyone's got here. So should be interesting. Thinking first topic of discussion, kind of near and dear to everyone's lives. And I'm sure it's had impacts all around. Overall, in terms of, impacts everyone living with COVID and how things have changed. In terms of how you guys have operated, maintained anything as it pertains to your dry scrubbing solutions, how's COVID impacted you guys essentially? And I guess Spencer, we'll start with you first on this one, sir.
All right. As far as our NID systems, we've been fairly lucky. Like I said, we don't use lime, so we're getting our lime kiln from the CFB from a local mine here. So our supply for the bag house has been pretty good. But as far as manpower, if the quarantines have really been an issue for us. If one person gets it, he's working with 5 guys. They all go home for a week. So that's been our biggest issue.
Okay. How about you, Gary?
Yeah, we've had some outage issues. We had an outage rescheduled. We were scheduled to replace half the bags and some of the cages in a bag house, and we postponed that outage. And then we decided to go with a short duration outage to see if we could get a couple of the compartments changed out. We were able to get 2 of them changed out, but everything kept rolling to our next outage, which is coming up in February. We're going to have to do 8 of 10 compartments for the bag house. So it's kind of compressed everything to the very end where we have to get a lot done quickly. And of course, COVID's still not over. I don't think we're going to have the issues we had in the previous outage, but obviously it can, raise its head when you're, trying to get this many contractors on site. And the deliveries, I had to, make sure that I placed all the orders early for the bags, for the cages, to make sure they were here. In fact, as we're talking, an email just popped up that my cages are on the way. So that's a good sign.
Matt, how about you guys?
Yes, sir. The lead times on the materials definitely impacted all of us. We too we had to really sharpen our pencils and order bags and cages well ahead of time of a spring rebag chance and follow it through to completion. Gone are the days where you can just place the order and it's going to show up on time. It takes a lot of specific tracking. We are being impacted, at least across our fleet, in available skilled resources. We don't get quite the draw on all craft, laborers, carpenters, boilermakers, electricians, etc. And it is beginning to impact us. A warm body isn't necessarily a skilled body. We're not even getting all the warm bodies anymore. So we are having to consider extending outage durations and struggling with that in outage scheduling opportunities.
That's interesting. Fritz, how have you guys been impacted?
Of course, initially in 2020, it was a big impact when a lot of unknowns out there. We had to reschedule our planned outage where we were changing out the bags in the Alstom NID bag house. So we had to do a partial change out where we did less than 1,000. We changed out the ones that had repeated failures, and we executed that outage this spring. But then along, same as everyone else has mentioned, supply lines, we've had to do some early orders, plan ahead on a lot of that. There's a lot of things, especially I've noticed in the electrical equipment and architectural type stuff. for extremely long lead times. And then as far as the labor, it's affected us somewhat, mostly with our contract labor for our laborers, carpenters, millwrights, etc. It hasn't been too bad, but it's been enough where we've had to make slight changes and sometimes even offering and or considering offering subsistence pay. So it's having an effect. It's not extreme up here in northern Minnesota, but it definitely has an effect.
Okay. Andy, last one to chime in on this.
In the beginning in 2020, in the spring and in the winter and the spring, we had canceled all our outages. So basically no outage happens in the spring. And then what happened is a big burden because everyone's outage was in the fall of 2020. And then you had to wear masks all the time. We did have a few workers that got COVID. If you were exposed to COVID, to the person either in close contact and, an elevator or something like that, you went and got tested. Okay. Luckily, we didn't have the people that did have COVID because we were wearing masks. They didn't spread it to too many people. So they just, I don't know where they got it from, but luckily it wasn't spread throughout the whole plants. And then now it's like we're in an outage right now, and because of the vaccination, it's a lot easier. You don't have to wear a mask if you're vaccinated. We do have a problem getting contractors, getting people, boilermakers, pipe fitters, but we seem to get just enough to get the work done. I mean, we don't have what we'd consider a full crew, but they work a little bit longer and we're able to get things finished and maybe extend the outage a week or something like that. Okay.
Okay, sounds good. It sounds like from what I'm hearing from you guys though, basically make sure folks are doing their homework on lead times, because obviously they're different than what they were. Sounds like potentially, extended outages due to, the resources that may or may not be available. So it just sounds like a little bit of homework and an upfront planning to make sure that, you guys are properly prepared. So well, one question from the audience, because I think this came up a lot when you guys were talking about, the ordering cages and bags, et cetera. There was a question that, what kind of bag life are you guys experiencing in your bag house with these CDS and NID systems? And kind of leave it to you guys to chime in as appropriate. What are you guys seeing?
I could say that our Edgewater plant, the unit was started up in 2016. And we have not changed the bags out yet. And we can get into it a little bit later, but the bags are still looking pretty good. The perms are still good. We seem to be in good shape. At our Lansing station, due to a lot of corrosion in the Hamon Research Controlled Bag House, we had to replace half the bags, and it's a circular, the bags are placed in an arrangement around the circular tube sheet. And it seemed that the bags that are in the center of that got a lot of corrosion and a lot of, just rust and everything from they called it the chicken foot that turns around, it spins around and pulses the bags. So there we replaced in 2019, we replaced half the bags there. Because those were the worst ones. And the outer half, we haven't done anything yet. Well, the unit's going to close down, going to shut down next year. So we're probably going to run till that with those remaining bags.
Okay. Any of other panelists that you got any feedback you want to share for the question?
Yeah, on our Alstom NID design, they had predicted a full bag changeout in 3 years. As things got pushed, and then of course COVID pushed another year. We ended up changing them all out, all 19,440 of them this spring. So that was a 5.5 year runtime. And we found that the Alstom NID has a imbalanced flow through them. Where typically on one side or the other of the module, you get kind of a turbulent flow that causes damage to the bags up at the top in the cuff region. Those had been changed out more frequently. We've had some of them as many as 3 or 4 failures. When you eliminate basically those first 2 rows, the bags that we changed out after 5.5 years were actually still in very good condition. They had increased from about 5, 6, 7 inches of DP across them up into the 13, 14 inches of DP range. So they were getting closer to the end of their life as far as that. But other than the flow imbalance damaged ones, they actually held up very well.
Good. Good.
Yeah, we're
Um,
getting 3-year life out of ours. However, the COVID situation, where we're now running into 3.5 years now, and we're starting to get some bag leaks, but we're able to, manage until the upcoming outage.
Okay.
On our Alstom NIDs, we're getting about 3 years life with the CFB burning up to 30% ash, an opacity limit of about 2%. We have to have very good bag control. And best we've got is about 3 years.
Okay.
Now, one of the issues that we've had is the cages themselves. They were carbon steel as they were installed, and we were in the process of replacing them with 304 stainless steel over time, and so we could actually pull the bags off the cages. The last short duration outage we had stainless steel bags lined up. Stainless steel cages lined up, and we had to cut the cages. The fabric was just so embedded with the rust on the back cages. The only solution was to cut them loose. So this next outage, I've got all new cages coming in except for the stainless steel that we have. So that is an issue that we have had and noted.
Okay.
Okay. Matt, did you have any thoughts on the bags? I don't think I.
No, thanks for calling me out on that.
No, you're good. I didn't know if you just wanted to.
Our experience is similar to what Fritz described in regards to the flow distribution issues with the Alstom NID/bag house design, and Alstom also worked with us for some flow distribution baffles that we put in on some of the units, and they're still in progress, that significantly reduced that flow distribution and fixed our issues. We also upgraded to a different bag design, top cuff, that Fritz is aware of. I spoke with him several months ago. We're working with a different bag vendor. That seems to be successful so far as well.
Good.
Hey, Jerry, another quick thing as far as general outage that we were discussing. The other thing is the price of materials has gone skyrocketed. I couldn't even purchase, number one, I couldn't purchase stainless steel cages for this outage because it was going to be 3 weeks after the outage started delivery wise, but the price had increased. It'd been, I think it's like 55% over what I previously purchased. So that's another thing you got to be aware of in our COVID days is budgets.
Yeah, I imagine that's a real challenge to try to properly budget when you guys are even a year ahead of time. It's got to be really challenging. Okay.
Okay. All right. Thanks, guys. So another topic here, and it's we hear about this kind of also being somewhat driven by COVID, but obviously gas and other changes we're seeing in the market are impacting this. But boiler load dynamics, you guys are having to run at lower loads more often. You're having to shut down for short periods, sometimes extended periods, just because the demand's not there. What are your all's thoughts, feedback, experiences that you've had with your different systems as far as running at low load and or shutting them down for short periods of time and then bringing them back online in relatively short notice? Whoever wants to go, I'll just leave it open if anybody wants to answer that.
Well, I can start, I guess. What's really been unusual in the last year, maybe a year and a quarter, because of the natural gas prices, our coal plants have been running like crazy. Edgewater ran, at full load, for almost a year, most just dropping maybe 50 megawatts. And that was unusual. Usually they drop down to, 120 megawatts, at night. And they're not just running the gas plants, so because the gas has been so expensive. That's at Edgewater. At our Lansing plant, 2 years ago, they were down almost, all winter long because the gas prices were so cheap. Again, now the gas prices are high, they're running like crazy, and they're calling them, to come back online. If they come down for an outage, you want you back online right away. It's really doesn't make any sense. And then the plants are closing next year too, so which is even crazier.
Anyone want to jump on that next?
I can step in here. The one thing that I've been at the plant about 3 years, so I don't have all the history, but one of the things that was done at the plant is we had two water injection nozzles. We have one vessel and we had two water injection nozzles as part of the design. And we were having some real trouble with pluggage at low loads with the two nozzles in service. So the plant engineer at the time designed a system to where at lower loads, the unit's rated 250 megawatts. At 120 megawatts and lower, we have one lance in. We put a center lance in. So we have an east lance, a west lance, and a center lance. So at low loads, we just use the one nozzle, and that has helped reduce pluggage of the absorber tremendously. And then when you get 120 megawatts and above, we put the two east and west lances in, and we shut the middle lance down. So that's been a real big help for us as far as pluggage. However, you know, at the lower loads we've been running, we've been cycling up and down. We still do get pluggage. We've now developed a way to, you know, unplug while we're online using water lances and things like that. I would say it reduced the pluggage down probably 80% or something. So we still get an occasional, you know, pluggage. And what we're finding is the nozzles, as the nozzle misbehaves and plugs, that's when you start getting sprays that aren't, you know, true to what they should be, and you start getting bigger droplets, and you start getting the pluggage down below the nozzle.
Gary, have you guys found any good metric? Like I've always heard or had the idea that, or thought that maybe looking at, say, the free moisture content and, you know, what's coming out of your baghouse. Have you guys found a good means to kind of identify and recognize when you're getting too much moisture in the process?
I wish I could say we had super analytical skills, but we go out and look in the dumpster at the bottom of the vessel. It starts looking muddy. We know we have a problem. And of course, the delta P, the pressure drop. But yeah, we have the operators go out at least twice a shift and look at the dumpsters just to make sure that it's not looking muddy. So that's kind of our analyticals.
Works for me. Matt, you got any feedback, or Spencer, Fritz? Anybody?
I'll go. Really don't have much help on this because with ours being coupled with the CFB, our turn down is limited to about 65% MCR due to NOx on a CFB. So we don't turn down that low, but what we do is we back off the temperature on the NID system as we do lower load. But we have the ability to make up for the scrubbing on the limestone that's injected into the furnace.
So when you say you back off on the temperature, in terms of the exit temperature, you use a higher exit temperature then?
That's correct, yes.
Okay.
Basically
Okay.
backing off the amount of water that's in the circulation.
Gotcha. Was that something you guys kind of learned through experience to kind of follow that? Otherwise, you're going to have some issues.
Yes, yes. I got too much ash in circulation for the low gas flow and couldn't lift it up the reactor duct.
Gotcha.
On our Boswell unit, we've, being that we're a very large unit with 9 individual modules, we don't typically have a lot of problem with lower load or turning back because we just start dropping modules. We'll get down to a base of 4. So we typically haven't had as much issue. We do get a little bit with mixer plugging. Again, I think that would go right along with Spencer's dropping the amount of water that goes into them, but we've been pretty fortunate for that.
All right, Matt, you got anything you want to add on to this that wasn't already said?
Just that with the NIDs and having those multiple parallel modules, we do experience the mixer and the hydrator pluggage, but we usually can postpone some maintenance until an off time when we don't need the load. So come down, and that is the next module that we'll take out of service and start working on concrete chipping, pressure washing, whatever we need to get that clean, return it to service. And our biggest leading indicator is the fallout of the NIDS J duct and the equivalent dumpster down below as well. We've got a normal amount of fallout, and then it'll talk to you when something's going awry.
Gotcha. All right. Anybody, any last closing comments on this subject? Otherwise, we'll shift to the next topic.
I just got a quick thing here, Jerry.
Yes, sir.
We obviously watch our temperatures too, as far as that's concerned. However, as we all know, you raise your temperatures, now your SO2 removal drops down. So it's that balancing act of, am I going to be in compliance or am I going to have buildup? So you develop a feel for that. The operators do on, how they manage it. But that is, something that we do also is the temperature, but, it impacts your SO2 removal efficiency. And then we get into mercury control. And we found temperature affects our mercury removal. So it's turned into quite a process rather than just, SO2. We've got other things going on that we have to watch. And so it's a balancing act.
No, I think that's a great point to be aware of. So kind of shifting the next topic, but kind of maybe somewhat incidental on that note is in terms of with your CDS NID system designs, what kind of instruments or data that you guys have had access to has been valuable for you guys to provide insights in both the scrubber performance as well as maybe even on the operational side of things to make sure that you're kind of staying in between the lanes and things are running how they should, or recognizing that you're starting to kind of deviate and you need to take action? Or along those lines, is there something that you don't have that you wish you had that would be helpful to sustain that? So, maybe Gary, well, do you have any insight on your experiences and thoughts on that?
Get unmuted here. I wish I could say yes, but we have the basic controls here. We have the outlet temperature of the bag house, outlet temperature of the CDS system, as well as the differential pressure, across the CDS, as well as SO2 in and out. So, we add line based on SO2 in, and then, differential pressure dictates our air slide height. So it's, we don't have other analytical things I would like to have. I think a dew point monitor would help out tremendously. But again, it's just not in the budget for us to get that. And then at the lower loads we're running, and, like I said, our units being converted to be able to burn both natural gas and coal. So the emphasis has been more on the natural gas than the coal. So we just have the basics that we need to run the system.
Gotcha. Matt, how about you guys at TVA?
Sure, I'd like to say real fancy equipment. However, I'd say the biggest benefit is correct gas flow measurement. And they went through a lot of pains during startup and revised the measurement system, but it basically, the OEM designed in a semi of a flow nozzle. We have multiple pressure taps and then correlate that. TVA utilizes our own test crew. So we took actual gas flow measurements, came up with a good correlation. And at least for these NID designs, accurate gas flow is, in my mind, crucial for the operation. That's also what drives the bag cleaning systems, not differential. It's the gas flows between the parallel modules. It also tells you when you have enough gas flow that you can start up the module and reduce your SO2 spike when you're putting a NID module into service. So that's probably our number one instrumentation system that works best for us, most crucial.
Can I ask a question on that there too, Matt? Gary mentioned earlier he kind of would like to have a dew point monitor analyzer in his system. I believe you have one. Have you guys integrated that into your controls at all to benefit you and your day-to-day operations?
I'm going to say maybe. I've not specifically said on that. We said it would be ideal. I think it's more of an interesting point. We operate more on temperature, the outlet gas temperature. The other instrument, it's a real, even for us, it's a large duct and it's one tiny monitor in the side. And we question how accurate it is or not. So I don't think it's tied in to the control system. And I may be wrong. And I'll probably get a phone call after this panel meeting.
Andy, how about you guys in terms of data accessibility to data that's helpful or something you guys wish you had?
We did put dew point sensors in. At Edgewater, we have 2 trains, and the one train seems to work real good, that we never have that many problems with the dew point monitor. The other one is nothing but problems. And no matter what we do, it just seems to give us problems. So we end up just going on temperature, since one was so bad and the other one, like we rely on temperature more than anything else. We did have at our Lansing plant, we did have gas flow, but because we had a hot side precip, it just coated the flow elements in ash, and we got terrible flow readings. It just went crazy. So we basically don't use that anymore and just go by load to say this is the flow. And then it actually, so a lot of times we'll use the flow, what we see at the stack, and convert it down to what we think it is at the scrubber.
Okay. Were you guys ever able to, you mentioned one of those dew point monitors worked well and one didn't. You guys ever do any digger deeping into, like, try and assess what the issues were?
We had it in there so many times for work on it, and we couldn't figure it out. I mean, that one that was on that one train just had issues all the time. Okay. So it still has issues, and it's like, okay, why is this one not working and the other one is? The other one was like, okay, some issues, but no great ones. This one is like a trouble to keep running.
Okay. All right. Fritz, how about you guys?
Most of the basic indication, a lot of them talked about, the gas flow, very important, the NID, the inlet outlet pressures, your temperatures, your inlet outlet temperatures, of course. One thing we pay particular attention to on our modules is the mixer amperage. We can get a pretty good indication of if that mixer is starting to get too much moisture in it or starting to get too much buildup on it, by watching the mixer amps very closely. On our unit, we were able to decrease lime usage to a point where we got to that threshold where we didn't have enough lime introduced to the system to negate the water that we're using to cool the stream. So we started building cement. So we draw a fine line there, and the more fresh lime we add into the system, the lower the mixer amps go, essentially, and less mixer pluggage. So that's something we watch very close. And something I would really like to find a better solution than what we have for it would be a broken bag detectors. Each module has a broken bag detector. It's basically one probe that sticks down from the top side into the flue gas duct. When we have smaller bag leaks, the ash tends to follow along the floor or along the tube sheet. It doesn't get airborne to the degree that the broken bag detectors pick it up. So it's frustrating. So we'll see it in the stack as high opacity, and then we end up going quite often into 9 modules to try to find out where we have broken bags. So that's a little bit frustrating, and something I'm hoping to solve with some different type of technology or something different for broken bag detectors.
Makes sense. Spencer, how about you?
Yeah, like Fritz said, we watch the mixer apps very closely and determine when we do need to clean a mixture. With the CFB ash coming, we're getting about 3 to 4 weeks before we have to clean a mixture. With 8 mixers on site, it seems like we're cleaning them nonstop. So another thing I'd like to have is a SO2 monitor between the unit and the bag house for the NIDs. The unit was supplied with one, but being a CFB with the high ash and the high lime coming out of it, we never could keep it running. So we really can't track the performance on the NIDs. We just track the performance on the furnace and the NIDs together. So it'd be nice to be able to separate those.
So you guys were looking to you said this was between the actual reactor vessel, the J duct, if you will, and the bag house itself is where you had a SO2 monitor?
No, it was actually on the economizer of the boiler.
Okay, I got you. All right. So you were trying to distinguish between the CFB scrubbing it and then the downstream.
Right.
Okay. All right. I got you there. That makes sense. Okay. one question from the audience, and this, I think you guys all touched upon it. So maybe, I don't know if anyone has any further comments, but question has been around the lines of, in terms of, we talked about whether it's a flue gas moisture or dew point monitor, whatever we want to call it. Has anyone found I guess, of what you would consider a viable solution or learned anything? And not necessarily to throw any specific vendor names, anyone under the bus or anything like that, whether it worked or didn't work, but is it something that anyone's had some experience or good lessons learned to hopefully kind of go down that path? It's been the topic of a discussion on the past DSUA webinar, so it sounds, intriguing. So I'd be interested to hear if you guys have learned anything along those lines.
I guess our solution on the NID is basically to raise outlet temperature, and which leads to a corresponding increase in hydrated lime. But the farther we get away from dew point, the less problems we have with our mixers and other equipment.
Gotcha. Okay. And then I assume everyone, it sounds like for the most part, everyone's controlling their water spray fundamentally using their exit temperature, not some other different piece of data or algorithm or something like that, which seems to be pretty common. Right.
Correct.
Gotcha.
I'd say that's correct, but there's probably some algorithm for a feed forward signal based on the gas flow without getting into intimate details, which I'm not knowledgeable of. And as far as the humidity, the dew point monitor, I know other vendors have contacted TVA before, and we're interested in it. I tell you what, bandwidth is an issue. Brain bandwidth is an issue for us. We can only stick so many irons into the fire. So I believe there probably are good vendors out there that are available, even some that have viable solutions. Right now, TVA's not dipped back into that to try to flesh all those out.
Understood.
And
makes sense.
the main reason is what we're all saying. We've got something that works. It's low tech, but it works and it gets us by. I think that's what it comes down to. These units are not slated to run another 40 years.
Yeah, and it sounds like the general philosophy here is, if you guys are having issues, like Fritz kind of described, the philosophy is rather simple, that you just kind of raise your exit temperature a little bit more, and there's that balance of sorbent utilization versus the back end handling issues, buildup, et cetera. But if you're having a problem, it sounds like that's the general consensus, is just raise your exit temperature. See.
One thing to add to that is, if you're trying to optimize your lime usage and SO2 removal efficiency at the lower outlet temperatures, corrosion becomes an issue. That's something we learned the very hard way, 10 years ago or 8 years ago. We had severe corrosion. So you've got to do, if you're going to operate at the very low temperatures, you've got to have an inspection plan to check thicknesses of your walls and things like that, or it can create a failure. So there's one thing to watch out for if you're allowing it to operate at such a low temperature.
When you say low temperature, Gary, what are you defining as low temperatures?
Well, I believe our guarantee was running, again, it varies from site to site, obviously, depending on the fuel, but we were running at like 160, 170 as our outlet temperature. We run at 190 to 200 now. So we, again, we had a failure of our absorber because of the corrosion when we were operating at that lower 160 to 170 degrees F.
I think that's a pretty good point. I would like to hear what everyone else's feedback is on what is their outlet set point operating temperature, now versus maybe sometime before, if they don't care to share.
No, I could share. We definitely had some corrosion issues after the first year, and our temperatures like 160, 170, and with the discussion with the OEM and then through just not wanting to go through that corrosion experience again, we raised it up to 180, 190. Okay. And just in the outage today, this week, we saw some more corrosion. So, you know, we had to install metal cladding over the cone of the CDS vessel 2018, and that material has started to corrode a little bit now too. So yeah, we had to raise it, even though, you know, we would like to have operated in the 160 to 170 range. Due to the corrosion, we had to raise it.
At Boswell, we've kind of settled in at the about 170-degree range. We've tried everywhere from, I would say, 155 Fahrenheit up to 185. 170 has been a good balance. We actually run tight enough in the summer, typically on hot days, where we'll watch the NID mixer amps go to almost max by the end of the day. Then we increase lime at night, as we sometimes typically drop load, and we'll watch that cyclic event, I mean, every day to almost where we trip out and back down by morning. So if we increase our temperature too much more, we have to increase more lime during the day, and it just doesn't work. So we're falling around that 170 range.
For the folks that were describing when you guys were saying you were seeing corrosion issues, was that due to like deposition buildup and corrosion that was occurring underneath that, or do you believe it was some condensation from some acids that, you know, from getting so cool? Like, do you have some root cause analysis when you guys say corrosion, like more specifically what kind of corrosion you were experiencing, and I guess where were you guys seeing it?
I could say we saw the corrosion from the Venturi tube sheet. That was really where it was the worst, right along, you know, the tube sheet, horizontal tube sheet in the slope cones, and then along the wall too, as it starts going up, the first 3 or 4 feet. This outage, we saw just the corrosion just at the weld line between the tube sheet, the Venturi tube sheet, and the cone of the vessel. And again, we saw some corrosion below the water injection lances. Okay. And I would say it was, I think the main contributor was maybe stagnation or cooling in that area. And that's where a lot of reagent was laying out too. So at times when you get down to lower loads. Okay.
I think ours, you know, was probably about 6 feet up the wall. And it was, in my mind, corrosion, cold wall impacts of condensation, you know, occurring on the walls. Again, there was some buildup, but I think it was mainly just the, you know, condensation of the sulfuric acid, hypochloric acid along the walls that caused the failure. Because our vessel actually failed, and we had to rebuild the vessel with the clad material. We had no cladding at all on the material, just straight carbon steel. So we do have a clad vessel now.
Okay.
We were lucky that our vessel didn't fail, but came awful close.
And Andy, what materials are you using to clad with?
We were using stainless, 304 stainless.
Okay.
But we, you know, that was on the tube sheet of the Venturi. On the wall, on the cone walls, they put back in, the OEM recommended using the same material and told us we were operating too close to the dew point. And so we put the same material in, and yeah, it's still corroded. So we should have put stainless in, but you know, we listened to what the OEM said, and you know, we thought we since we were operating at higher temperatures, we wouldn't have this issue, but you know, hindsight is okay. We should have put stainless.
Yeah, this happened before I came on board. So our management made the decision to put in C276 clad material. So we've got the Cadillac of the Cadillac absorbers.
Yeah, right. Exactly.
Wow. So you guys are, go ahead.
But you know what's funny is that's in Edgewater. At Lansing, we've not experienced any corrosion. It's an A36 material, and it operates in the 160 to 170 range. And they're both burning PRB, maybe a little bit different types of PRB, but you know, we went through the whole scrubber vessel and measured, and no corrosion. very minimal corrosion. So why?
Do they use the
you know,
same water source?
No, the only thing that's different is that Edgewater uses calcium bromide for mercury controls, and that might be what's causing the issue. More and more now, I think that's what's causing the corrosion, likely is the calcium bromide. Where Lansing does not use calcium bromide in their scrubber, but they use a brominated activated carbon for mercury removal. So that more and more, I think that's what's the cause of it.
We've seen that before, Andy. So we've talked quite a bit here about corrosion. I know we've got several of you guys here have full ash burden going through your system, and you've got some, especially like at Spurlock, even with that CFB. What kind of erosion issues are you guys experiencing, if any?
Oh, we experience a lot. With our reactor ducts and the recirculation plus the CFB ash, it literally ate our reactor ducts, and we did multiple claddings with AR plate, and finally ended up just replacing the entire reactor ducts with a densite lining on it. And since that point, we've been very good. We still have some erosion in the hopper areas of the bag house itself, but it's more manageable with AR plate. One note on the corrosion, we have very little corrosion, but what we do is on the tube sheets, and most of that is from air in leakage and cooling the gases off too much. So watch those gaskets up there.
Did you say, Spencer, was what you lined the new reactor ducts with?
The brand name's Densite. It's like a refractory. We put about a 1-inch coating on it.
Wow. At Boswell, we haven't seen much erosion in our reactor duct or our J ducts. I did some routine in there last spring and have not seen very much. We have seen quite a bit of wear in the bottom of the rotary ash feeders. We did a bunch of weld repairs in those units, but other than that, not very little problem with corrosion, and not yet, knock on wood, very much problem with erosion either.
We're still running our original J duct, but as soon as you hit that mixer level, it just ate it. We were looking at Swiss cheese for quite a few years until we got it replaced with a Densite line.
About Andy or Gary, I know you guys have more of the I'll call it the CFB style CDS system. You guys experienced any kind of erosion issues, whether, I don't know if you guys are injecting above, below your venturi, or you guys got any experiences either way with erosion?
We are injecting both locations below the venturis, and we have not seen that much erosion at all. Okay. But we do have, both units, we have precipitators, upstream, so that, and even though, I'd say that all fields aren't running, they still does a good job of removing majority of the fly ash.
Substantially just byproduct you guys are recirculating essentially. Yeah. Okay. How about you, Gary, on from your guys' perspective?
We have had some erosion in the venturis themselves. I believe we replaced the venturis 2 years ago, a year and a half, 2 years ago. So that'd give about 10-year life. So that's not a horrible life, for venturis, but yeah, we are getting some erosion. It's not what I would call excessive though.
Okay. Anybody else, anything they want to chime in on from the erosion side? We do have another question from the audience. I think is a good one that's applicable to everybody. Is in terms of this like startup and shutdown of your circulating dry scrubber NID system. What's been your experience in terms of bringing the unit online? At what point you need to, and are you guys able to sustain meeting your emission limits during the startup? And I guess how long does it take upon starting up your boilers to be able to actually start hitting your emission limits? Do you guys have any perspective or experience data on that you guys can share?
Well, with the CFBs, you know, we run limestone in the furnace, so most of our control's done there, but with the first generation NIDs, we can't even turn them on until 50% gas flow. Unlike the other two that have been talking where they can take modules in and out, we don't have that option. So we can't even turn it on until the gas flows high enough.
Okay.
Yeah, what we found is, and again, I'm not an integral part of that, but we have to have gas flow so we can create the differential pressure across the Venturi with the air slides in. And if we're coming with a hot startup, we have our air slides we just have the gates closed, and we can open the air slides up and let the feeders feed in. So we're pretty instantaneous if we're coming with a hot startup. If we're coming with a cold startup, we start with nothing. We end up with a little bit of ash, but a lot of lime. So we overscrub. So, you know, we can tolerate a little bit of startup hiccups because we're going to overscrub until we start getting the mixture of ash and lime in the air slides. So that's the way we kind of compensate for being, you know, say out of compliance for a short period of time.
Okay. Fritz or Matt or Andy, you guys have any experience, anything you want to offer on this subject as well?
Not a lot with the 9 module system. We typically fire on natural gas, and usually we put coal in at about 35 megawatts, give or take, and then they start up on 4 base modules. We typically don't have a lot of emissions trouble on startup. We'll get little spikes in opacity. Anytime you take a NID module in or out, you'll get a spike. We compensate for that and SO2 removal by a lot of times we'll increase the lime feed to that unit we're starting right before it starts up. So typically our operators are managing it pretty well.
And I'd say for TVA Gallatin, our units do not have a bag house bypass. So all the flue gas flow does go through the modules, whatever we have lined up. As far as a timeline, I don't ever track that. Of course, the corporate, I'm more the corporate engineer. The site engineers know more about that in ops. It is a function of the gas temperature and the individual module flow. Fortunately, we are capable of sending the flue gas through 1 or 2 modules for those startup durations. I know we're fully within our air compliance limits, and I guess no news is good news in this situation.
All right. Well, it sounds like you guys figured out strategies to manage the whole startup process and navigate through it without it being a significant issue for you guys so far.
So we've got another question from the audience here, and this has to do with kind of a multi-part question. So it's a quick lime versus hydrated lime, and if you use hydrated lime, you know, do you hydrate it yourself or do you purchase, you know, hydrated lime as it is? I realize this isn't necessarily applicable to Spencer, but the rest of you guys, I would appreciate, you know, your thoughts and feedback on that.
Yeah, we purchased Pebble line, and then we hydrate it with the Alstom design hydrators that are individual to each module. And it's actually, knock on wood again, been one of the pieces of equipment we've had very little trouble with. The hydrators have worked very well. They spill immediately into the mixer, which mixes everything past that point. But a few issues with the lime handling system, the Pebble line, the silo, some of the piping wearing out, issues there, but I think that's pretty standard to lime handling in general.
And Fritz, you're not testing any kind of outflow of that hydrator, are you, to check the BET or anything like that?
No, we're not.
Yeah.
I can say at Edgewater, they use Pebble lime and they hydrate it on site. And I think there was a few issues, you know, when they first started it up, but in talking to the operators late, you know, especially now, it's run very smoothly. They've gotten to, you know, handle it very well. In fact, it amazes me how clean it is around this hydrator. I know at Lansing, they they visited a few plants and didn't like the mess that was around the hydrators. I don't know which plants they visited, and they went to hydrated lime, and it works for them. You know, they don't have to worry about a hydrator. So I've got a mix of both.
Yeah, we get pebble lime here at Deer Haven, and we've had quite a bit of issues, you know, again, before I came, trying to resolve them. When you have moist Florida air and you have blowers that are blowing in moist Florida air into your transport system, that cause some pre-hydration is what I'll call it, hydration in the lines and the silos. So we have had issues with that. And also the other issue we have is if we store it in a bin somewhere over an hour or two, it solidifies, so we have luggage issues. So our operators have it down to a science, so we can come out of our pebble lime silo and all the way through the system into the hydrator as one continuous stream, rather than using the various hold points and storage points. So once they get it set up, and that includes a bucket elevator, so they've got it down to a science where they can go all the way from the silo all the way through and into the hydrator and then to the hydrated lime silo. They've worked hard at getting it that way, but they have it down to a science. And so we've not had many issues. And the control is strictly temperature. You know, the operators just watch the hydrator temperature, and that's how they control how much is going into the hydrator. Again, it feeds all the way back to the storage silo. We do have the capabilities of putting in hydrated lime, but that's only for backup. And we've used that a couple of times when our hydrators are out of service. We have one operating and one standby hydrator. The biggest issue, which I think is in a lot of these systems, the CDS systems, is the hydrator was oversized. We would love to have a continuous feed from the hydrator into the CDS, but our feeds are too large. Our hydrators are too large. So we have trying to balance that is an issue where we overfeed into the absorber, into the absorber, and then we underfeed and we overfeed is because our feeders are not designed for the lower feed we need at the lower loads that we're running.
So for I heard both Gary and Andy talk about times you guys have used hydrated lime, or I guess Andy at one of your facilities at Alliant, you guys are doing that routinely. How is that? What's kind of been your normal staff, or how many hours? Like, can you I guess quantify or assess by using hydrated lime instead of quick lime, like how that's kind of freed up your maintenance and operations team? Or do you guys not normally have a lot of folks that are kind of assigned to having to deal with the hydrator / reagent prep side of things that provides much value for you guys? I guess I'm trying to assess and understand, what that hydrate versus quick lime, operating the equipment versus buying a hydrator, like what the pros and cons you guys have experienced since you have that perspective.
I guess that at Edgewater, they were very adaptive at, once they got the hang of the hydrator, they were very adaptive at making it work very well. It's just, they're very good at that. And they haven't had that many issues and lime handling issues. Besides that was really the only issues, maybe a little bit of pluggage. Once they ran it and got accustomed to running the hydrator, it became something they just dealt with. It was really not that much of a problem for them. Luckily, they must have had a couple, I'm not every day at the plant, and especially now with COVID, we try to minimize people. I'm in Madison, not at the plant, and they try to minimize our visits to the plant because of COVID. So I have to most of the time work from home. So it's, kind of hard to, get in touch with these guys on an everyday basis.
Yeah, understood. Makes sense. Well, so kind of, I guess, tying into that, this is, I guess, more of just a general question for you guys in terms of the CDS NID solutions you guys have had. Maybe you guys are just going to reiterate something that you've already spoken, but what are, I guess, your biggest challenges that you guys are currently dealing with nowadays with your CDS / NID system? What are the biggest challenges you guys are trying to solve right now going forward?
I'd say one of the biggest challenges we had at our Lansing generating station was operating at low load. And when they'd operate at low load, they'd plug up the NID, the CDS, and they must have plugged it up 3 or 4 times. I mean, plugged it all the way up to the Venturis. And we talked to the OEMs and the, Burns and McDonald, and they offered to do a big in-depth study for us about, what we need to do to change the controls and the operation of the unit. And this unit normally would operate with a DP across the scrubber vessel of 6 to 6.5 inches. And we just reduced that to 5, and it seemed to stop it. And what was happening, and we never could figure it out, was they'd be operating the unit at lower load, and all of a sudden the slide gates would start opening without even, nothing, no one touched anything, and they start opening, and they'd flood the CDS with material. And since we've changed the DP setting on it, it hasn't happened. Okay. And they also put an alarm there so that if all of a sudden that gate starts to open, oh, we'll catch it and stop it. But that was like going on for maybe 9 months to a year. And then we decided to just change the DP in the scrubber.
So do you guys have a recirculation duct, right? That is there some recirculation duct essentially that's fundamentally designed with like a damper to try and sustain a minimum velocity? Was that not effective enough for you guys or did it not operate, or was the logic like how, I guess the intent of that was supposed to be to keep everything entrained, right? So it doesn't
correct. But for some reason that slide gate would just open up. Okay. And we could never, we never could catch it and we did look at the controls and stuff like that. And, it's like, well, why is it doing it? We never could figure out why it was doing it. Okay. And finally we changed the DP, made it, lowered it to 5. And it's really strange too, because the Andrus design scrubber operates at a 4 to 4.5 inch DP. The B&W one operates at a 6 to 6.5. Okay. So, and then, sometimes when they're operating at lower loads, the operators like to play with that DP read. They'll put they have some flexibility into changing that DP, and then they'll, when they're at load, then they continue on and they forget to take that out. Okay. So, I don't know how many times they had to go in there and, vacuum out, and actually not vacuum, but, actually chop it out because it was hard as a rock. So, and, then I look at Edgewater plant and you look at the bottom of their scrubber and there's never any material in it. Okay. It's maybe, it's so clean, it's ridiculous, the only difference in the actual scrubber or vessel shape is one is on the one at Lansing, it's just like an elbow. Okay. On the one in Edgewater, it is more like a hopper on the bottom there. So the material actually, it's a slight cone to it. So that material actually falls into the ash collection system, gets ground up and moves on. So maybe it's just, the elbow design is not conducive to having the material flow into where the grinders are and, collect it up and bring it out, where this, the hopper one is more conducive to that. So you don't have to worry about the buildup.
Okay. Spencer, what about you guys in terms of just what kind of challenges? What are your biggest challenges you guys are trying to work through at this point or plan to work through in the near future?
Well, we have 2 different challenges. One is we're still fighting erosion. Our typical life on a temperature element, a thermal probe, is lasting about 2 months. And that's right at the top of the reactor duct, and it just gets the tip eaten off of it, and then starts to suck outside air and then screws up all the controls. So we're still trying to figure out a way to get either weld overlay or ceramic coated or something there on that well to help it last longer. And the other big thing we fight is opacity. Like I mentioned earlier, our opacity trigger is about 2.5%. So about a quarter size hole in one of those 8,000 bags will put us over our limit. So we go into compartments quite a bit trying to find those.
Doesn't sound like fun.
No.
Needle in a haystack is what comes to mind.
Bag house bingo.
Well, at least you guys have been able to make it fun by the sounds of it.
Yeah.
No, I appreciate that. Those sound like real legitimate challenges to find a hole that small and all that available cloth area. So, Fritz, how about you guys? What are you guys facing for challenges at this stage?
Right now, we've faced from the beginning is trying to reduce or eliminate would be nice, but at least reduce mixer pluggage. I mean, that's a extremely hard spot to crawl into and clean. It's dangerous. You got the big elliptical blades in there that get sharpened by wear. That's been a challenge since day one. One I'm dealing with right now is the actual, in the bag house, the actual pulse tubes are starting to wear. They're a little bit loose where they slide onto the J tube that comes down into the tube sheet area. So they have a little bit of slop in them. So every time there's a pulse, that tube lifts and pushes out. So it's cutting and wearing into the steel 3/8 inch bar that retains it from going out at the end. And then also wearing out the end of the pulse tube itself where it slides over the J tube, and eventually it gets bad enough where the tube blows right off. So we're looking at doing some pretty major redesign of those areas, putting sleeves on the ends that wear out with a bolt that is able to tighten it down into the J tube. And then I want to do a redesign of the whole fastening system on the other end.
Gotcha. Okay, Gary, how about you guys?
Repeat low loads. Obviously, that's the issue a lot of us are dealing with. The original vessel that we had did not have observation ports in it, so we could take a look inside the vessel. So we have observation ports now. So what we do is we will be doing inspections inside, looking inside the absorber vessel while we're operating. We can actually shut off the air slides and have gas flowing through, because since we have a precipitator upstream, it is clear enough to where you can actually see if there's buildup along the walls or on the venturis. Now, since we can co-fire natural gas, that makes it even better. We can actually convert over to natural gas if we see a problem and go in and do an observation through the observation ports. The other thing that allows us to do is if we're burning natural gas, obviously, we don't have to worry about SO2 limits, so we can actually go in and take 1 or 2 days to actually clean the pluggage up while we're online using air lances and various sundry tools that these guys have that we use. It's not easy, but we don't have to come offline. That's one of the conveniences of having the natural gas. Before the conversion, we were not able to do that. We would be able to go in and take a look and see what we had, see how it was performing, and make a schedule. Okay, we have pluggage. We can schedule an outage to come out for the pluggage. The other thing is we're going to start doing more inspections of our nozzles. We have a test stand right next to the module, and make sure that because if those nozzles start generating larger water particles, you're going to have problems with the pluggage. So we're going to start put a plan in place to start pulling those out more often and doing inspections to see how the spray pattern looks and things along those lines.
Makes sense. Yep. Matt, how about yourself? What are you guys looking to do going forward? And what kind of challenges do you guys trying to eliminate, I guess, and navigate through?
But before I answer that, let me ask a follow-up to Mr. Grubbs. So just out of curiosity, on our SDA vessels, we've got some buildup on the sidewalls. It's kind of similar to the concept of the CDS and pluggage. We have not investigated this, it's just a brainstorm. Has anybody done in our bowlers, we use shotguns to knock off a slag, and we can do that because we've got thick water walls, etc. Have we considered doing that with plastic or rubber, any other type of explosive propulsive device to knock off that buildup, short of dynamite? And I can say we've all had to use dynamite and det cord in our bowlers. Any type of cleaning system?
We've not had to use that at ours. They have what they call a whirly bird they put on the end of their pressure washer that kind of goes in and digs through it. and we chop it up in pieces and let it slide down into the Venturi, into the grinder. So no, we've not tried anything like that.
All right, copy that. Yeah, and I know in coal bunkers, we've used a different type of whirly bird with the brass chains that hydraulically spins around.
I've seen that.
All right, so challenges for TVA Gallatin. Ours are the biggest ones that I hear about are outside of the actual NID vessel itself. It's bag and cage failures. We think we've got a handle on that now. It has to do with flow gas distribution. We put in baffling with Alstom's design help to redirect our flue gas down these alleys that exist on the NID baghouse designs. And then the other big item is dealing with a pebble lime conveying system. On our pebble lime storage silos, we've had vibrating live bin bottom. 3 out of the 4 have failed disastrously. So we have to keep our eye on that closely so that we don't have any failures. And then just the conveying from the main storage silo over to our day bins. And I think what the plant's doing there that's been successful is basically it's like they put a 454 big block engine into a Pinto, and we got too much horsepower in our blowers. So we're trying to shove way too much air over into our day bins, which have too small a dustbin on top. Then that all plugs up, and then that reduces the flow, and then that leads to pebble lime convey pluggage. So what they've done is they've slowed down the blowers, pebble lime convey blowers. And I'm pretty sure that's been successful to reduce our pluggage on the other end, which overall keeps us from dropping too low on our pebble lime conveyor. So those are the biggest items.
All right. Thank you guys. I appreciate that.
Okay. Thanks, guys. We've got another question from the audience here. So sometime back, we were talking about, how we were raising outlet temperatures in order to mitigate moisture and pluggage issues. Have any of you experienced any, issues or related impacts to your mercury control set points and permit limits as a result of trying to find that sweet spot on outlet temperature set point?
We have, yes. When we try to blend our coal, it's difficult for us to do because we don't have the capabilities really to blend it. It's where they bulldoze it in, and we try to mix it if we have a high mercury coming in. So we'll get these plugs of high mercury coming in. And what we have found is if we do lower the outlet temperature, we don't know the science behind it, but that it does reduce the mercury emissions. Now, we've also started a program which we use on an as-needed basis of putting in carbon into the baghouse, a couple of baghouse hoppers, to allow carbon to circulate in the CDS as well as on the bags if we need kind of a shot in the arm to reduce the mercury. So yeah, that's kind of our experience with mercury control. And that's the only control we have with the mercury.
Anyone else have any experience or anything to add on to Gary's comments?
We have not seen that much, we don't have that. We have firing PRB coal, and we have not seen that much difference with temperature. Also because at one plant, Edgewater, we use calcium bromide and activated carbon. And like I said, we have not seen it, but then we operate with such low flows of activated carbon. In fact, we use more calcium bromide than activated carbon. So we basically just over inject with the activated carbon. And what we did see though, just recently this year in both units, is that our activated carbon lances have been corroded to the point where they're falling apart. And at Edgewater, they were adding more and more. They didn't realize this was happening, and they were adding more and more calcium bromide. And when we went in October at Lansing, we noticed that 3 lances were broken and the other ones were corroded up between the ductwork and the flange of the activated carbon lance that was just packed with fly ash, and it corroded the lance out. So then this outage here we're at Edgewater, we went and pulled our lances and they're all corroded too. So I would say, and they've not been in the system that long. I think at Lansing they were in since 2010. At Edgewater, they changed them in 2012 was when they installed the lances. So I would say the biggest problem we've had is just with the lances, and not with, varying temperatures, because when everything's working right, we're injecting such low flows of calcium bromide in pack, it's, we can't really see a difference. And the system was designed, well, all our pack systems were designed with, hundreds of pounds an hour of carbon, and we're not using anywhere near that at Edgewater. At Edgewater or at Lansing, we're using probably 150 pounds an hour, but that's brominated pack. Here at Edgewater, we're probably using 10 pounds an hour of carbon. So between 10 and 15 pounds an hour, I would say.
And this is Matt Wilson at TVA. So we've not made note of a direct correlation between our outlet temperature and our mercury. However, I will say our systems are set up. Each unit has its own flue out the stack. So each unit has its own mercury sims. And what we did is we tied in that mercury sims, and it's the controller for our activated carbon injection system. And it is quite interesting. So the majority of the time, we don't have to run carbon. We hit our turn on threshold. The system starts up. We have one lance per NID module. It's in the middle at the top of the JDUP. It turns on, injects for a little while. I don't even know the exact amount of time, but it's not days and days. It's basically get enough carbon into that system. Mercury level comes abruptly down. And then through that natural recycling system, it stays in there for days, and our carbon's able to be turned off. That is unique, that we have that unitized approach, that we probably need to write up and better share that, just how that pans out, since not everybody might have the opportunity to see exactly this carbon does that. And then you turn it off and it keeps recycling in, and then it slowly ebbs away, and then you get back to your turn on threshold again. So a truckload of activated carbon lasts us a long time.
I think just to kind of tie into that in general, a question for our panel is in terms of consumables. So I'll put this as, I'll call sorbent, whether it's quick lime, hydrated lime, pack. You guys spent some extensive time talking about filter bags. I'll put them in there, or spray nozzles, or even water, whether it's water quality. Like what have you guys, what are good lessons learned that you guys have picked up over your operational experience in terms of these consumables that you, I guess, wish you knew at the start, or that'd be worth passing on to some of the other folks out there in the industry? Fritz, do you want to kick us off on that one?
Yeah, I don't have a lot on that subject. I would say, we did quite a lime reduction effort in the first couple of years of operation. We actually got to the point where we had to put different VFDs and motors on our lime screw conveyors because the feed rate was so slow. Ended up getting too slow, of course, and plugging mixers up. But other than that, I mean, we've had lessons learned with the bags, with that flow imbalance and the Alstom NIDs, where we come up with the reinforced cuff for the bags. But yeah, not a lot else, I guess.
How about you, Gary? Anything you want to add in terms of consumables you haven't already kind of spoken about so far?
Not really. I guess the one thing that, I come from a wet flue gas desulfurization background many years. And I was used to more of, let's look at the slurry. Let's look at how much calcium sulfate we have. Sulfites was, something you utilize quite a bit to to tune your FGD systems. What I'm finding with the dry systems, and again, it has to do with budgeting and everything else, is, you know, if you could analyze how much excess lime you have going in your byproduct, you know, would help reduce your amount of lime consumption if you can make adjustments and things like that. But you know, here at GRU, and I'm sure throughout the industry, you know, due to, you know, lack of budgets, you know, that's just not in there. So you know, we kind of do it, like I said, what we're talking about here, doing it by temperature or by, you know, looking at the byproduct, see what it looks like. It's more of what we're doing. So if I had my wish list, it would be to have more analyticals along those lines.
That makes sense. Spencer, how about you?
Probably the biggest thing we've learned over the years is to add some more instrumentation. We got a very bare bones bag house from Alstom, and you know, watching the pulse count on your bags is very important. But what we didn't have, and we've installed here in the last 5 years, is pressure transmitters on all the pulse tanks. So with those pulse valves, if they stick open, you've lost an entire compartment because there's no pressure to pulse. So we were running blind on that for a lot of years. And then once we got the installed 24 transmitters per unit, we got the visibility of those pulse headers, and we're able to keep better track on the pulse count and maintaining those pulse valves.
Andy, how about you? Anything on experience, lessons learned on consumables?
Say, you know, it's at Edgewater, you know, because of the corrosion we experienced, we just had to deal with using more lime because we were operating at higher temperatures and we were trying to save the scrubber. And then, you know, our other consume like bags, so far we've not had to change bags at Lansing or at Edgewater, excuse me. And our calcium bromide and mercury are always low to begin with. So, you know, the systems were never designed for that low a flow. I think, you know, we anticipated a lot more flow of calcium bromide and a lot more flow of packed. And it seems like we're nowhere near what we designed the systems for, which has created a lot of problems because, you know, we've had to change the control system out on some of the trains in the activated carbon system because we just couldn't adjust it. You know, we wanted to go lower, but we couldn't get the system to operate any lower. So we changed the controls out so we could lower it. And even doing that, we were still, you know, operating very close to the end to the bottom of that system. So, you know, it was kind of hard to optimize when, you know, you don't have budgets are tight and you don't, you know, you try something and every time you do something and optimize a little bit more, you're finding that, oh, I could go lower. But again, it's limitations of the system you can't control.
Gotcha. All right, Matt, what do you got? Enlighten us on consumables in your experience.
I won't try to repeat what the others have said. The last individual was just talking about, reminded me when we did the design for the dry scrubber, we made up a controversial design code. Meaning, what I mean, we made up. We did it as a team. We knew that we were going to be operating from 100% PRB to 50% PRB, 50% Illinois. So the sulfur had a huge range, 0.3 pound SO2 per million BTU up to 3.1 pound SO2. If we had just spec'd 3.1 and then operated 100% PRB, we would have been sunk on our turn down capability across that whole range. And we continue to do so on chlorine, on ash, and we ended up with a made up fabricated coal. But the concept was to try to push our designers into giving us something that could vary on range. Both on the mercury as well. So we were fortunate that our team agreed to do that, make up that coal spec. The designers, our engineering firm, did not want to do that. The OEMs did not want that. They just wanted to give me one number for sulfur, one number for mercury, one number for ash. And we all know it's especially more realistic now than ever before. These coal mines shutting down, we're going to get this huge variety of fuel coming into all of our plants. It could be a shovel bulldozer full of this and 3 bulldozers full of that, or it could be coming from a terminal if the terminals don't shut down, etc. All right, so I digress. The only other thing I'd say on the NIDs is the NID design, it utilizes quite a few nozzles. And I would say that is a weakness. Our nozzles are not operations proof, meaning some feller's idea of cleaning them out is to take it out and beat it against something hard nearby. And that works for a while. But what it does is it ends up damaging the pretty light gauge components, or it knocks some deflector tips loose. So we've had to do some spot welding. The plant came up with that as a response to fix things and to fix some of our pluggage issues. But I wish we had a little bit more robust nozzles, more robust design, make it more real world proof, I guess. Because right now it looks really good on paper, but it doesn't hold up as well in the field. That's all.
I have trialed some different nozzles here at Boswell. Matt, if you're interested in maybe speaking about that later. I had some very, very robust designed ones. They were more difficult to clean, so the operators weren't in love with them, but you could throw them off a building and you wouldn't hurt them. So if you want to talk about that at a later time, let me know.
Yes, sir. Thank you.
All right. Thanks, guys. So I know we're running short on time. I'm going to ask probably a quick question here. I think I probably know the answer to, but I get asked all the time from people, what is a use of CDS NID byproduct material? Is there a use for it? And I'm just curious if any of you on this panel have looked into it and have found a use for the byproduct material from your systems. A beneficial use, let's put it that way.
At Boswell, we
Stabilizer.
dry cell it. We blow it over to a silo. We truck it to our dry cell. I would also be very interested if there's any beneficial reuse. And one that I thought about many times as also being a part-time farmer is for land application, because I think the NID byproduct has more lime in it than, obviously much more than a wet scrubber's waste stream would. Just by the nature of how the NID works, you have a constant stream of removal out of there that's got unreacted lime in it. So that's always been something I've been interested in, if anyone has any experience with that. But other than that, we haven't found anything we can use it for yet.
Yeah, we landfill ours, so there's nothing that I'm aware of. I know years ago, in my previous career, we were doing some studies and we just couldn't find anything for the states just are hesitant to approve things because of, potential, impacts with mercury and things along those lines.
Gary, have you guys had any challenges with landfilling? Landfills have any questions or give you any technical issues, concerns about putting the material in a landfill?
We do on-site landfill. So we have, a separate permit from the state of Florida. So we're able to do it our way. It is a line, it is a lined area and that sort of thing. We meet the guidelines, but yeah, we do it ourselves on site.
We also landfill all our material on both Lansing and Edgewater on site. So we don't, it's permitted for that and we haven't had any issues.
Travis, I expect that was the response you were going to get. You were expecting to get, I guess.
Yeah, pretty much. And even I've had people ask about the use that Fritz pointed out for agricultural. And once again, the mercuries is always what sends up a red, or the metals is what sends up a red flag there. So I was just curious.
Yeah. Well, I think it seems like the path that to go down always starting is understanding the quality, the chemistry, and the consistency are a good starting point. I think to at least having some data to hopefully find someone interested to develop a solution or work on that solution. So that was a great question, Travis. I get that question all the time as well. So someone figures that out, then they'll solve a lot of the problems out there people are looking for. So guys, does anyone have any we're down to the last minute, but any last closing statements or anything to close us out? Yeah, I just want to say thank you to you guys. This information is extremely helpful. You guys have been doing this for a long time, and I think learning from the experience of others hopefully prevents us from all having to go up the same learning curve. And we appreciate your time, and hopefully we'll have you guys back again some point in next year, whether it's a webinar or another panel session. But thank you again, and thanks for all the audience members joining. And yeah, look for the recording. We'll get this posted here coming shortly. And if anyone thinks of any questions or wishes to get a hold of any of the speakers, just connect with us through the DSUA website, or if you got our email or LinkedIn page, send it to us directly. But thank you guys, and have a good one, and we'll catch you at the next DSUA webinar.
All right.
Thank you.
Yep.
Thanks, guys.
You.